Welcome to the first of our extra videos of Chapter 5. Today is day 20, completing the square. Today's video and tomorrow's video are both on completing the square. There's two reasons to complete the square. The first one is so that you can solve quadratic equations using the square root method. So that's what we're going to do today. And then tomorrow we're going to convert quadratic equations from standard form to vertex form. So today is going to focus on the square root method. So we're going to review that first. So there's two problems to review. It says solve using the square root method. The first one is x squared equals 48. Because we have the x squared alone, we can take the square root. I then need to simplify root 48. 48 is 4 multiplied by 12. 4 is 2 times 2. 12 is 4 times 3. And 4 is again 2 times 2. I have one pair of 2's. I have another pair of 2's. And then I have that 3 left over. From each pair, 1 comes out. So 1, 2 from the first pair, 1, 2 from the second pair. The 3 stays under the root because he doesn't have a partner. So this becomes 4 root 3. And then remember, because I took the square root, I'm going to get a positive and a negative answer. So that's my final answer. So that was the first type of square root problem that we did. On the right is the second type of problem. I have the quantity x subtract 3 squared, add 5 equals 86. So I'm going to subtract 5. I get x subtract 3 squared equals 81. Take the square root. Remember that the squared and the square root undo each other. They're inverses. So I am left with x subtract 3 equals. The square root of 81 is 9. Remember that because we decided to take the square root, we put in the square root, we should get two answers, positive and negative. Add the 3, I get x equals 3 plus or minus 9. It's very tempting to leave it that way. Don't leave it that way. 3 add 9 is going to be 12. 3 subtract 9 is negative 6. So these are our two answers. So that was stuff that we should know how to do already. Now let's move on to a more difficult example. So initially, when we saw an example like example 1, solve using the square root method, we would say, well, we can't use the square root method because we have an x squared and we have an x term. So can't use the square root method. Well, we're going to try to factor this. So we need to know the two numbers that multiply to 25 and add to be negative 10. Well, hopefully you know that that's negative 5 and negative 5. So we have x subtract 5 equals 27. This becomes x subtract 5 squared equals 27. Okay, now if I move back, that looks similar to this review problem on the right that we did. We have a quantity squared equals some number, so I can take the square root. So if I take the square root, I get x subtract 5 equals plus or minus. Now I need to simplify the 27. 27 is 9 times 3. 9 is 3 times 3. So I have a pair of 3's and one 3 left over. So I have x subtract 5 is plus or minus 3 root 3. Remember, 1 3 from the pair came out. This extra 3 is what stayed under the root. Now when I add 5 over, I get x equals 5 plus or minus 3 root 3. These are not like terms, so do not add them. And that is our final answer. So what we're going to be doing today is we're going to be taking a trinomial, factoring it so that it's a perfect square, and then taking the square root. What you need to know is this term has to be the middle term, has to be b divided by 2, and then squared. In this case, our b is negative 10. So we have negative 10 divided by 2 squared gives us that 25. But that's not always going to be the case. So let's look at example 2. If I take this and I divide it by 2 and I square it, 16 divided by 2 is 8, squared is 64. Well, that is certainly not negative 9. So that negative 9 is not going to let me factor this trinomial perfectly. So let's think, two numbers that multiply to negative 9 but add to be 16. Well, those don't exist. That's why I know negative 9 is not the right answer. So I'm going to move 9 to the other side. So I have x squared add 16x equals 9. Now, in order for this to be a perfect square, like we had above we had the x minus 5, in order to get that, we're going to need to add in this 64. Because I'm adding to the left side, I also have to add to the right side. Okay, so I told you you're going to have to take the b term, divide it by 2, and square it, which is what I did. That's how I got this 64 here. Now I should be ready to factor. Two numbers that multiply to 64 but add to be 16, well, that's 8 and 8. So I have x plus 8 equals 9 add 64 is 73. Now this is a perfect square. So I have x add 8 squared equals 73. Now I have a term squared equals 73, so I can take the square root. So I'm going to do that. Square root of x plus 8 squared is x plus 8. And then I get plus or minus root 73. If I subtract 8 over, my final answer is x equals negative 8 plus or minus root 73. And that's my final answer. Again, I know that's confusing, so we're going to do another example together before you do one on your own. Flip to the... Okay. So this next example that we have is something new. Example 3 is something new, so we're just going to skip that one for right now. Let's go to the one more example. I don't know where this little arrow came from, but I told you this last term has to be the b term, so negative 10 divided by 2 squared. Negative 10 divided by 2 is 5, negative 5, and then squared is 25. Positive 9 is certainly not 25. So that positive 9 is not going to allow us to have a perfect square trinomial. Thinking, two numbers that multiply to 9 but add to be negative 10. Well, that's negative 9 and negative 1, which is certainly not the same number. So, as we did before, move that 9 over to the other side. So I have x squared subtract 10x equals negative 9. Now, in order to have a perfect trinomial, I'm going to need to add this 25. Because I added it to the left side, I'm also going to add it to the right side. Now, my right side, or my left side should factor. Two numbers that multiply to 25 and add to be negative 10. Well, hopefully we know that's negative 5 and negative 5. So I have x subtract 5 equals negative 9 add 25 is 16. So this becomes x subtract 5 squared equals 16. If I take the square root, I get x subtract 5 equals plus or minus 4. So this gives me x equals 5 plus or minus 4. So x equals 5 plus 4 is 9. 5 minus 4 is 1. So x is equal to positive 9 and positive 1. Before we do that example 3, I'm going to have you write down one example to do on your own, please. So I would like you to do x squared add 6x subtract 7 equals 0. I would like you to solve using the square root method. So again, you're going to have to start by taking this b term, dividing by 2, and squaring it. Pause the video right now and try this one on your own, please. Good luck. Okay, let's see how we did. If I take the b term and I divide by 2, I have 6 over 2 squared. 6 divided by 2 is 3. 3 squared is 9. So I need this number to be a 9. So I'm going to add 7 to the other side. Okay, I know I need to add 9 to both sides. Now, two numbers that multiply to 9 and add to be 6, well, that's 3 and 3, which is exactly what I want. So this becomes x add 3 squared equals 7 add 9 is 16. So this becomes x add 3, after I take the square root, plus or minus 4. So I get x equals negative 3 plus or minus 4. So x equals negative 3 add 4 is 1, negative 3 subtract 4 is negative 7. So hopefully that one went well for you. because we are going to add one more step. So let's go back to example 3. The reason we skipped example 3 before is that we have a 2x squared here, which is going to throw things off. All the other examples we did had a leading coefficient of 1, had a positive 1x squared. So we need to get a positive 1x squared. In order to do that, I'm going to divide everything by 2, the entire equation. So I get x squared, subtract 4x, add 3 equals 0. Now this looks like what we did before. So this needs to be negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Squared is 4. I need a 4, but it's actually a 3. So what I'm going to do is I'm going to move that 3 over to the other side. Okay, now I'm going to add a 4 to both sides. Okay, on the left side, two numbers that multiply to 4 but add to be negative 4. Well, that's negative 2 and negative 2, which is good. It should be the same. So I get x subtract 2 squared equals negative 3 add 4 is 1. When I take my square root, I get x minus 2 equals plus or minus 1. So x equals 2 plus or minus 1. 2 add 1 is 3. 2 subtract 1 is 1. Okay, let's do one more example. So next to this example that you wrote before, you're going to write a new one. This time, 3x squared subtract 18x add 27 equals 0. So, clue, the first thing that you want to do is divide everything by that leading coefficient of 3. And then it's exactly what we did before. When you come to class tomorrow, we will be checking to see that you have this completed. Good luck.